Hello, everybody. Chemical reaction. So I'm just going to go over what chemical reaction means. There are so many reactions that happen between chemicals. So that before they give you a final stage, for example, you have chemical A would react with chemical B, and then they provide for you a product, chemical C plus D. Or it could be this, we call this reactant. We call this reactant. We call this product. All right. So how do enzymes facilitate life? That's the main question. How do they facilitate life? Enzymes are involved in every chemical reaction that happens in your body. Every chemical reaction that has to do with digestion of food or breaking down of food in the body, releasing enzymes, or making it easy for respiration, for digestion, and everything. So among the new words we have is chemical reaction, reactant, products, activating energy, catalysts, enzyme, substrate, and active site. When we talk about a process is a series of steps, or actions that produce an end product. So when you have several steps or series of steps which you have to go through to give you the end product, we call that a process. So it could be A plus B will produce C. Then C plus D produces E. Then E plus E plus F produces G. So, and G is our final product. So after that, we're not going to proceed anymore. But we can have an intermediate product like C could be an intermediate product because it's a product from reactant A plus B. And C became a reactant combined with a D to give you product E. And product E also became a reactant to react with F to give you product G. So this is what we call a process, a series of steps or actions that produce an end product. A chemical reaction is a process by which atoms or group of atoms in substances are reorganized into different substances. So the meaning is if you are having, let's say, for example, we have water plus salt, right? Though this is not chemical, let's use a normal chemical reaction. Let's use a chemical reaction where, let's say, we mix the magnesium plus chlorine to give us magnesium chloride. So magnesium is an element, so it's going to react with chlorine. Before the reaction between magnesium and chlorine, there will be a breaking down of the atoms of magnesium into smaller particles. So the atoms of magnesium will be shattered into smaller particles, and the substances of chlorine will also be broken down into smaller particles. So after this breaking down, so that's the reason it says is a process by which atoms or group of atoms in the substances, they have to be broken down first, then reorganized to form a new product. They're going to be broken down, reorganized. Because you would, if you see the magnesium chloride, it's not going to look like magnesium. It's not going to look like chlorine. It's going to be a different thing. So this is the reason why whenever you want to talk about a chemical reaction, it is a process by which atom or group of atoms in a substance are reorganized into different substances. Chemical bonds are broken, so the chemical bond holding the magnesium atoms together would be broken down into smaller particles. The chemical bond holding the chlorine particles together will be broken down into smaller particles. So they will come together to form a new product called magnesium chloride. What are the clues for chemical reaction? What are the things you see to know that a chemical reaction has taken place. There will be production of heat or light. There will be formation of new gas, liquid, or solid. So the meaning is you're not going to get magnesium at the product. You're going to get something else, magnesium chloride. You're going to get sometimes a liquid. You can combine one solid and liquid together, and you get liquid. You can even combine gas and liquid together and have a liquid, or gas and gas to get a solid. So it's not going to be the same as what you have in the reactant. It's going to be a different thing. So that is a chemical reaction. Substances can also undergo physical changes. The changes can change. I mean, there could be physical changes in in substances, which can change the appearance. For example, when you have a cup of water, so you put it in the freezer and it becomes solid. So that is a physical change. Or you have a solid, you put it in the sun and it melts, it becomes liquid. Then it evaporates and becomes gas. So this is physical. Why is it physical? Because you could reverse it. When it's reversible, or no new products, or not something different. It could be that thing, but different form. All right. So when it's reversible, it's called physical changes. But if it's irreversible, it's a chemical change. Chemical equation describe the substances in a reaction. What does that mean? The meaning is when there is a chemical reaction, we have a reactant to form a what? To form a product. So reactant are the starting substances on the left side of the arrow. While the product, they are the substances which is formed during the reaction on the right side of the arrow. So the arrow indicates the process of change. So the arrow which you see here indicates the process of change. It can be read as yields or react to form. It could be read as yields or react to form something. So meaning the reactants react together to form a product. In every chemical equation, there is a law that says a law of conservation of mass that says in every chemical reaction, matter cannot be created nor destroyed. So the amount of matter you have in the reactant should be the same as the amount of matters you have in the product. So all chemical equation must show this balance of mass. The balance of mass means the number of atoms of each element. The meaning is you have 6 carbon here, you must have 6 carbon here in the product. You have 12 hydrogen, you must have 12 hydrogen here in the product. You have 6 oxygen, you must have 6 oxygen here in the product. You have 12 oxygen, you must have 12. So 6 plus 12 is going to give you 18 oxygen total in the product. So this is what they mean by chemical balancing of chemical reaction. So I give some examples which you can try to do yourself. Let's say, for example, I have the C6H12O6 plus O2, then gives me 6CO2 plus 6H2O. Someone looks at this will tell me it's not balanced. It's not balanced because the number of oxygen we have in the product is 6 times 2 is 12. 6 times 1 is 6, meaning 18. But here we have only 6, meaning there's something wrong. So you have to balance it. You have to say 18, 6. So we have to put what? We have to put 6 here times 2 to give you 12. So 12 plus 6 gives you 18. So now it's balanced. So this, I gave you some examples in the class, so you can try to review those things again. Activation energy is the amount of energy which is needed for reactant to form products. So the meaning is the amount of energy, the minimum amount of energy which is needed for reactant to start the process of changing to become a product. So some reaction really happen because they have a very high activation energy. So this is energy and this is the reactant process. So these are the reactants here. X plus Y are the reactants. They have to overcome the activation energy and before they form a product. So in that process, the energy releases all of this. So the meaning is let's say for example, this is 0, this is 1, this is 2, this is 3, this is 4, this is 5. Meaning we have 5 joules of or kilojoules of energy in the reactant, but in the product we have only 1. What happened to the 3 is been released here. So it's been released. So that's the process of reaction. So energy change in chemical reaction. Reaction that releases energy in the form of heat is exothermic. So when they release energy to the environment, so this one releases energy is exothermic. All right, it's exothermic. So because it's got so high energy in the start, and at the end it's got very low energy, meaning 3 joules of energy is lost to the environment. So an exothermic reaction shown on the left side of the next slide. Reaction that absorb energy in the form of heat is endothermic. So when it absorbs energy in form of heat is endothermic. Endothermic reaction is shown on the right side of the next slide. So you can see, so this is exothermic, as I said to you before. Why? Because we have 4 and we have 1. So if you subtract the product from the reactant, so once you have less product then the reactant is exothermic. So, but once you have more product, more energy at the product than you have in the reactant, the meaning is energy is absorbed, so it's endothermic. It's endothermic. So energy is absorbed to the into the reaction process. All right. So all living things are driven by chemical reactions. Okay, I said to you before in the beginning, every reaction in the body happens through the process of chemical reaction. So additional substances are needed to reduce activation energy. So the activation energy, if it's to be brought down the more, they would need some other substances. So a catalyst is a substance that lowers the activation energy needed to start a chemical reaction. So a catalyst is a substance that lowers the activation energy that is needed to start a chemical reaction. Catalysts do not change the amount of product produced, nor are they used up in a chemical reaction. So a catalyst is being used to make you get your product faster. So by lowering the activation energy, which you have to overcome before your reaction starts. Catalyst would not be part of the reaction. It's not going to join to be the part of the product, or it's not going to be part of the reactant. So it's just going to be that it does not take part in the reaction. So when the reaction starts, it's going to be what it is. When the reaction ends, it's still going to be what it could be. So there is no way it's going to form a new thing. So special protein called enzymes. So these proteins are called enzymes. They are biological catalysts and they help to speed up the rate of chemical reaction. Most enzymes are specific in the reaction. So this is an example of a reaction where you have a reactant. And this is a reaction with an enzyme. But this one is enzymatic. So you can see the activation energy is made shorter and the product is got faster compared to this. So this is what the enzyme does. So the reactant that bind to an enzyme are called the substrates. So whenever the reactant binds to an enzyme, is no more called a reactant, it's called a substrate. So the specific location where a substrate bind on the enzyme is called the active site. So the specific site where the enzyme binds is called the active site. So this is a substrate, this is enzyme. So it has to fit in the space. It's not possible if the enzyme does not have the same shape as a substrate, it would not work. So this is why enzymes are very sensitive in the reaction. There are some basic factors that can affect enzyme activity. Each enzyme has a range of conditions in which it is most active. Factors that affect enzyme activity include the pH and also the temperature. So we have some substances we call inhibitors. So these inhibitors can bind to an enzyme's active site, preventing the substrate from binding to the enzyme. By doing this, they slow down the rate of chemical reaction. So which of the following is a substance that lowers the activation energy? Is it ion? Is it reactant? Is it catalyst? Is it substrate? Is catalyst? Which statement is true of chemical equation? Reactant are on the right side, product are on the right side. So reactions are on the left side and product are on the right side. So this is true. Which describes an exothermic reaction? They release energy, they require energy, they create energy, they destroy energy. They release energy. They release energy to the environment because before, in which of the following are bonds broken and new bonds are formed? Is happening in a chemical reaction. Which of the following decreases enzyme activity by binding to the active site? They are the inhibitors. All right, this marks the end of the lesson. Thank you very much.